Example 5. Part 1, use the sigma notation to represent 2 plus 6 plus 10 plus 14 plus ... for 45 terms. Part 2, for what value of n is sigma, so the sum of all values of TR, which in this case is 3r minus 5, from 1 to n equal to 90. So n is the unknown value, that's what we're trying to find. And part 3, find the value of sigma, so the sum of all values of TR, which is 4r minus 1, from 1 to 8. So part 1, we're going to start with our sequence. So 2 plus 6 plus 10 plus 14 plus ... So we find A, the first term, which is 2, and the common difference ends up being 4. Then we write out Tn, our nth term formula, which is given in your formula book. Tn equals A plus n minus 1 times D. We replace A with 2 and D with 4. And then we multiply out the brackets and simplify, so we get Tn equals 4n minus 2. Now all we have to do is replace both of those n's with or. So we now call it TR is equal to 4r minus 2. So therefore, 2 plus 6 plus 10 plus 14 plus ... for 45 terms is equal to, so sigma, so the sum of all values of 4r minus 2 from 1 to 45. So or can be replaced with a set of brackets in 1. And 4 times 1 minus 2 is 2, which is the first term, which again, that's what we started with. This is just showing an example of how the statement or the formula actually works. Just notice in this question that we're just assuming or is equal to 1. We just assume that 2 is the first term of the sequence unless we're told different. Part 2. So we're going to just write down what was given in the question. So sigma, so the sum of all values of 3r minus 4 from 1 to n. So n is the unknown value. That's what we're trying to find out. So we're going to write out TR, which is 3r minus 5, replacing or with a set of brackets. And into the first set of brackets, we put 1 because we're starting off at 1. And in the second set of brackets, we put 2, then 3, plus ... up as far as 3n minus 5. So this would represent the last term. We don't know what this is. N is what we're trying to find out, the last term. So 3 times 1 minus 5 is minus 2. 3 times 2 minus 5 is 1. 3 times 3 minus 5 is 4. Plus ... 3n minus 5. Again, this just stays the same. This just represents the final term. So A is the first term, which is minus 2. And we get the common difference to be 3. So A is equal to minus 2. D is equal to 3. We're going to write out our sum of series formula, which is Sn equals n over 2 times 2a plus n minus 1 times d. We're going to replace the a with minus 2 and the d with 3. We know that Sn is equal to 90, so that's the sum of the terms. So Sn is equal to 90. The sum of all the terms added together is 90. The a we swapped for a set of brackets and minus 2, and the d we replaced with 3. So next we're going to multiply out the brackets and simplify. Notice that now we just have n's. That's the only variable that we have in our equation, are n's. And that's what we're trying to find. Going back to the question, it asks us to find n. So from here on out, it is just algebra. We're going to multiply out the brackets, simplify and solve. So multiplying out the brackets, inside of the square brackets, we get minus 4 plus 3n minus 3. Which simplifies to 3n minus 7. So next we're going to try and break up this fraction. So this is n divided by 2. So the opposite of divide by 2 is multiply by 2. So we're going to multiply both sides by 2. So we get 180 equals n times 3n minus 7. Then multiplying out the brackets, we get 3n squared minus 7n. Bringing everything over to the left of the equal sign, we get 3n squared minus 7n minus 180 is equal to 0. So now we have a quadratic trinomial. Again, go back to the question. We're trying to find n, so we just want to solve for n. At this point, you can factorize and solve, or you can use the minus b formula. So I just wrote this out again from the previous slide. So I'm going to factorize. I'm going to use the arrow method. So 3 times 180 is 540, and we have a lot of factor pairs for 540, so this is probably a longer way to do it than minus b. Sometimes factorizing is quicker. In this case, it's probably not, but I'm going to show you both methods. So we bring down the 3n squared, we bring down the minus 180. This minus tells us the signs are different, so we've got plus something n minus something n. We're going to choose one of the factor pairs that will end up giving us minus 7n. So one has to be a plus, one has to be a minus. So we're going to go with 20 and 27. So the 20 must be positive, the 27 must be minus, because we need to end up with minus 7n. And 20 minus 27 is minus 7. So then we're going to factorize the first two terms and factorize the second two terms. So factorizing the first two terms, we get n times 3n plus 20. Factorizing the second two terms, we get minus 9 times 3n plus 20. Notice that you've got the same thing inside of your brackets, inside of your eggs. So you've got the first part of your answer. So 3n plus 20 is the first factor. And then n minus 9 inside brackets is the second factor, and that's equal to 0. Now again, we're trying to solve for n. We're trying to get n on its own. So we have to let each of the sets of brackets, or each of the eggs, equal to 0. So we end up with 3n plus 20 is equal to 0, and n minus 9 is equal to 0. So this is just written out from the previous slide. So we get n is equal to minus 20 over 3, or n is equal to 9. Now if you wanted to use minus b, this is your minus b formula given to you in the formula book. No need to learn it off. We label a, b, c. We sub into the formula. We simplify. And we're left with 7 plus minus root 2153 over 6. So then we're going to break this down into two parts. One with a plus, one with a minus. And with a plus, you end up getting 9. With a minus, you end up getting minus 20 over 3. So just like the same answers we got when we factorized. So it's up to you which method you want to use. As I said, in this particular example, minus b is a little bit quicker, but not always. Okay, so n is equal to 9, or else n is equal to minus 20 over 3. So that's from the previous slide. But since n must be an element of the natural number set, n is a positive whole number because it's an amount of something, n must be equal to only 9. So n is equal to 9, so the first 9 terms add up to 90. So if you were to keep going and adding on, you would eventually get up to 90, and you would count that you have 9 terms in total to get to 90. Part 3, find the value of sigma, so the sum of all values, of 4 or minus 1 from 1 to 8. So I'm going to write out 4 or minus 1. I'm going to replace the or with a set of brackets, and I'm going to put 1 into the brackets to start off with. So this time or is equal to 1 starting off. And then I have 2 in the brackets, 3, 4, 5, 6, 7, and 8. So 8 is the final number inside our brackets, and we have a full stop. So 4 times 1 minus 1 is 3. 4 times 2 minus 1 is 7. 4 times 3 minus 1 is 11. And we get 15, 19, 23, 27, 31. So it's 3 plus 7 plus 11 plus 15 plus 19 plus 23 plus 27 plus 31. Full stop. So A is the first term, and plus 4 is the common difference. So D is equal to 4. So using our SN formula from our formula book, we're going to replace the A with 3, the D with 4, and we're interested in the first 8 terms because we have 8 on the top of sigma. So we just sub in our values. So 8 over 2 and 8 minus 1 in place of the ends. And we get 136. So otherwise you could just add up the terms. So 3 plus 7 plus 11 plus 15 plus 19 plus 23 plus 27 plus 31. And again get 136.